Example 1. Prove by the mathematical induction 1 plus 2 plus 3 plus and so on up to n is less than 1 by 8 times 2n plus 1 whole square. First, for n is equals to 1, left hand side term is equals to only 1 and right hand side of the inequality 1 by 8 times 2n plus 1 will become 2 plus 1 taken whole square, nothing but 9 by 8 greater than 1. So RHS is greater than LHS. So LHS is less than RHS and therefore statement is true for n is equals to 1. So P1 is true. Now we assume that let P k be true. That means we assume the statement is true for k values, which implies left hand side 1 plus 2 plus 3 plus and so on up to k is less than 1 by 8 times 2k plus 1 whole square. This you call it as condition 1. Now I have to prove, yes. So to prove statement for k plus 1. To prove the statement is for k plus 1, that is we have to prove that it is 1 plus, that is we have to prove 1 plus 2 plus 3 and so on up to k and k plus 1, the summation should be less than 1 by 8 times 2 into n replaced by k plus 1 and then plus 1 taken whole square. So I have to prove this condition. So consider LHS of this statement P k plus 1, statement for k plus 1. It is 1 plus 2 plus 3 and so on up to k and then k plus 1. The first terms, k terms is nothing but actually according to from the condition 1, which is less than 1 by 8 times 2k plus 1 taken whole square and plus k plus 1, right? So let me take up here right hand side term separately. So 1 by 8 times of 2k plus 1 taken whole square plus k plus 1 is equals to LCM. When you take up, this will become 4k square plus 4k plus 1 plus 8k plus 8, and that is written it as 1 by 8 times, this is a 4k square plus 12k plus 9, and that of course is 1 by 8 times 2k plus 3 whole square, and that is written as 1 by 8 times 2 into k plus 1 whole square. Therefore you got LHS is equals to 1 plus 2 plus 3 plus and so on. That is nothing but this particular part, and that particular part is less than. So 1 plus 2 plus 3 plus k plus 1 is less than 1 by 8 times this one, you got it. So 2 into k plus 1 taken whole square. This is nothing but RHS value in case of statement for k plus 1. That implies pk plus 1 is true, and therefore I say that the statement Pn is true, okay, for all n belongs to capital N by mathematical induction. Right? Hence the proof.